Hi everyone, welcome to our YouTube channel Incredible Maths. This channel provides solution to previous year CSIR NET mathematics problem. In this video, we will solve two problems from part B of linear algebra asked in CSIR NET September 2022. We will see the first problem. Let us define a sequence an where n belongs to natural numbers. Sequences of real numbers to be a Fibonacci like sequence if an equal to an minus 1 plus an minus 2 where n greater than or equal to 3. What is the dimension of the real vector space of Fibonacci like sequence? The options are 1, 2, infinite and uncountable. The fourth option, infinite and uncountable. So n term of the sequence is defined here, that is an equal to an minus 1 plus an minus 2. So we need to find dimension of the vector space. So to find dimension, so first we will find the basis. So we will write this the first term of the sequence. So the first term is when n is equal to 3, so we will get a3 equal to a2 plus a1, where a1 is the first term of the sequence and a2 is the second term of the sequence. Third term is a3 equal to a2 plus a1, and the fourth term of the sequence is a4. a4 is equal to a3 plus a2, which is nothing but, so a3 we can write as a2 plus a1, so a2 plus a1, so which is equal to a2 plus a1 plus a2, so which is 2a2 plus a1. And now a5, the fifth term of the sequence is a4 plus a3. So for a3 we can substitute 2a2 plus a1, and a3 we can substitute a2 plus a1, so which is nothing but 3a2 plus 2a1. So when we do like this, so each of the terms of the sequence depends on a1 and a2, and finally our nth term will depend on the two terms a1 and a2. So therefore the basis of this vector space is repeated. So the basis of this vector space will consist of two elements, so that is a1, two vectors a1 a2. So here the number of elements, the basis is 2, so therefore dimension is 2. So therefore the correct option is B equal to 2. So now we will see the second problem. Let A be an invertible 5 by 5 matrix over the field F. Suppose that characteristic polynomials of A and A inverse are same. Which of the following is necessarily true? The first option, determinant of A square equal to 1. Second option, determinant of A power 5 equal to 1. Third option, trace of A square equal to 1. And fourth option, trace of A power 5 equal to 1. So here we will consider a matrix A such that it is an invertible 5 by 5 matrix. So for simplicity, we will take the matrix A to be an identity matrix of order 5 by 5. So clearly identity matrix is an invertible matrix, so automatically we will have a characteristic polynomial. So now we will find a determinant and trace of this matrix. So determinant of this matrix, so for that we need A square and A power 5, A power 2. So A power 2 will be equal to A into A. So that is A is equal to AI and So this will be equal to I into I is equal to I. So this implies a square equal to I, and similarly a power 5 will also be equal to I. So a power 5 can be written as a square into a. So a square into a square is I, and I into I is again I. So we will find trace and determinant for these two. So for a square, so let us find determinant of a square. So determinant of a square is nothing but determinant of I. So this is 1, and here determinant of a power 5. So determinant of a power 5 is also equal to 1. Next we will find trace of a square. So trace of a square will be, so a square will consist of a square is equal to I. So therefore in the diagonal entries we have 1, and the rest of the entries are 0. So when we add all the diagonal entries, so we will get 5. So trace of a square is nothing but sum of all the elements, all the diagonal elements in the matrix A square. Okay. So here trace of a power 5, so this is also equal to 5 because a power 5 equal to identity matrix. So from this we can eliminate the third and fourth options. So third option says trace of a square equal to 1. So here we get trace of a square equal to 5. So this is wrong. And similarly the fourth option, trace of a power 5 is equal to 1, it's given. So according to our example, so trace of a power 5 equal to 5. So therefore the fourth option is also wrong. So now we left with the two options, determinant of a square equal to 1 and determinant of a power 5 equal to 1. So therefore we will take another example. So different example satisfying this one. So here if a is equal to I, and this implies a inverse is also equal to I. So therefore so this our matrix A satisfies these conditions. So similarly we will take another A satisfying this condition, that is characteristic polynomial of that matrix, and its inverse are same. So we will take a 5 by 5 matrix. So here we will take it as A is equal to minus I. So negative of identity matrix. Okay. So here what is A inverse? So A inverse is also I. So we will get A square equal to I. So A square equal to I, and okay, so this implies A square equal to I and a power 5. So what will be a power 5? So a power 5 equal to, so minus I into minus I into minus I, so 5 times. So we will get minus I. So for these two we will find trace and determinant. So first we will find determinant. So determinant of a square. So determinant of a square is 1, and what is trace of a square? So trace of a square is 5. And determinant of a power 5. So determinant of a power 5 equal to minus 1. And what is trace of a power 5? Trace of a power 5 is equal to, so a power 5 is minus I. So therefore we will get minus I. So on all the diagonal entries we have minus 1. So minus 1 5 times you will have minus 5. So therefore this option, determinant of a power 5 is equal to 1, is wrong. So the correct statement is determinant of a square equal to 1. So if you like the content of this video, kindly like, share with your friends. Also subscribe our YouTube channel to get latest videos and notifications. Thank you.